All right. I think I am live. We will wait for confirmation from the chat. Let me know if my audio is okay or I need to adjust the levels. And once we have that confirmed, we will hop into things ASAP. David says, sounds good to me, so we're off to the races. All right, I guess technically, Happy New Year. I think I've made at least one or two YouTube videos since the beginning of 2024, but this is my first, I think it's my first live stream of 2024. I'm almost certain that's the case. And hope everyone's having a good 2024 so far. I decided to do this live stream at the last minute because I did a bit of Jello programming on the weekend. I kind of wanted to live stream, but ended up not doing it. But then figured I would leave a few things for the next live stream, and I've got some time tonight, so we are going to stream for maybe an hour, maximum 2, because it's 9 p.m. local time in Toronto, Canada, and I got to go to sleep at some point. But yes, for those of you that are tuning into this live stream for the first time and haven't caught live stream number 1, 2, 3, or 4 for this Jello project, I guess actually that's not what we want to do. We want to F11 this. Jello is a Python script wrapper around the Jelly programming language. Technically, the Jellyfish programming language, which is a fork of the Jelly language. Jelly is a code golf language, so everything in yellow here is basically the Jelly programming language. So similar to APL and J and BQN, it uses odd symbols to represent expressions. And basically what Jello is it is a keywordified. In other words, it adds atoms. It adds keywords for each of the atoms. So in Jelly or Jellyfish, atoms are each of these Unicode symbols. And Jello basically adds a keyword for each atom. So R stands for range or iota. And so in Jello, we just added a keyword here. And F is for flatten. Flattens a nested list of stuff into one sort of list. And so we added the keyword flat, etc. That's the overview we're going to give. If you're interested, feel free to check out the other live streams where we kind of build up this tool. And yeah, the color coding, green is for unary or monadic functions, blue is for binary or dyadic functions, functions that take 1 argument and 2 arguments. And then prior and scan, the red functions are for quicks, or what other programming languages called higher order functions. Mjolnir's Revenge asks, will there be a remote portion for the NVIDIA conference this year? Not going to be able to fly out to see Jensen. I actually don't know. I know all of the GTC talks will be online at some point. Whether or not live stream or not, I actually don't know the answer to that question. We can just go check. I guess I probably should know, seeing as I work for the company. I'm not going to be there in person, at least at the moment, unless there's some last minute thing. It's in person this year, first time since the pandemic. Yeah, it doesn't send. You can just Google it, figure it out. But yeah, all of the talks will be online at some point. So, anyways, what are we going to be doing today? We're 5 minutes in. We haven't done anything yet. Hopefully, we're going to close 2 or 3 issues. The first thing I want to do is I want to figure out a nicer way to spell a solution I coded over the weekend. Then we're going to look at some of the we're going to solve a couple. We'll just cherry pick ones that are going to be probably pretty easy. if we go to challenges, I sort of got up to 250. So we're going to look at 251 to 257. So there's like, what, I don't know, 12 or 14 problems in there. And then if we get through all of that stuff, I want to look at this issue that was opened by Tom Huntington. And, you know, if we blaze through all of that stuff, maybe we'll do something else. But first things first, let's look at this. So yeah, this was 250. So for those of you that don't know, Perl Weekly Challenge, it's just a weekly website that releases these kind of like leak code-ish problems. It's just another resource on top of leak code to kind of find these, you know, small problems that are fun to solve. And so the one that I solved was this smallest index. So you're given an array of ints, and you're supposed to write a script to find the smallest index such that the value or the index mod 10 is equal to the value. So basically you've got, if we go to Jello, say we just choose some random number and then we go iota, we're going to get a list. And then if we go mod 10 on this, you see we basically get this just repeating sequence from 1 to 9. I guess technically we should do, what is this, iota 0? And you get 0 to 9, 0 to 9, 0 to 9. So basically the problem is asking, given sort of that infinite sequence, what's the first value? Oh, and I guess you're supposed to return -1. Well, we ignored this, this part of the problem. Anyway, so how did I solve this? Let's just see if I can, and so this is the interesting test case here. 4, 3, 2, 1. So if we do a iota 0, or technically it's len iota 0, right? You can see that if we compare these, the only value that is equal to the index mod 10 is the value at the third index, aka 2. So I think if you go equals, this will automatically form the sigma combinator, which is basically going to compare this sequence with the original sequence, and then it'll give you a mask corresponding to all the values that are equal. And then if we do a monadic separator and we do index, that'll turn all of our ones into the corresponding indexes. And then if we go at index, except I think we have to do that. And then in case we have multiples, so like say we were to change this to 3, this is going to give us back now two values, and we only want the first one, which you get by typing head. So this currently, if we go back to the issue, yeah, len iota 0 mod, did I do mod 10? I didn't do mod 10. Technically there should be a mod 10 in here. It doesn't matter for this because we have less than 10 values. Mod 10 equals dot index colon at index head. This is what we need to solve this, but I'm pretty sure, like, this is irritating to me. So if we just create what do we want to do here? Say we do this iota, and then we go, is there an odd? Yeah, there should be an odd. And then we go, so like basically I want to be able to do, there is a keep, hey? So is it keep? So first of all, we got to figure out what keep does. But basically we've got a Boolean mask, and you should just be able to type something like compress or keep instead of converting these to indexes and then doing a dyadic separator with at index. Except that didn't work. Index. What is this doing? Well, first we have to figure out what's wrong here. Iota odd index so what's happening here? Oh. So this forms sigma. Well, let's go to yeah, this. So what is this thing? X is the left argument, Y is the right argument. Return the elements of Y at index X. Well, let's just try. Right, this is not the mask we want. So let's do this. 10, 20, 30. So we basically want 1, 3. Yeah. So the question is, oh, right. So see the issue here? I'm assuming that this is the list, and we don't have that. So let's just put the list in here. And now, once again, that's kind of confusing. So let's add 11, 33, 55. Right. So the question is, what does keep do? What does keep even? So I don't even. First of all, I don't even have this open right now. So tokens, where's keep? Keep is dyadic. So it's in these, and was it G? What was it? It was P. Partition Y at the truthy indexes of X without keeping the borders. So it's keeping 20 and 40. How is 0 the truthy value here? And also that is so odd. Well, yeah. It's partition at. I see. Well, I don't really want a partition function. I just want like a compress hash base decompression. Yeah, well, so I mean, Mjolnir's Revenge is saying this is noise, so we can do a little digression. What we're basically trying to do here, we've got some, sequence of values, and then we're doing something like this, where like this is, so we're figuring out which values of x are odd. And then with that, we can perform a compression where basically we get rid of everything that corresponds to a 0 and keep everything that corresponds to a 1. And you can do that like that. And technically, you can make this point free by doing this. Isn't that beautiful? So this is basically, this is a function called replicate or compress, and I want this, because currently what we're doing is we're getting the indices. We're doing something like this, where we get the indexes of the values we want, and then we're doing like some kind of selection based on that. And that's like unnecessary. I just want this compress function. And so that's what we're trying to figure out how to do in Jelly right now. Which is why I'm searching for like, there's no filter, I don't think. Huh. There's a filter. I mean, my audio is a bit low. Let's go adjust the gain. This should be a lot better, hopefully. I'm not in the red, but now I'm in the yellow, so let me know if that's better. So there is a filter. Remove the elements from X. That are in Y. So we kind of want, we could use this. Well, let's go do this. Let's go get this function. And I don't think I have this. So this is technically like a remove. What should we call this though? A remove? Technically, APL calls this without. I don't like remove, but sans. Yeah, I mean that's cute, but I don't like that either. Oops. So I mean to do rename, but let's, because then technically what we can do is we can just multiply, and I know multiplication works. So if we go odd, and then we go multiply, and then we go 0 remove. What? Remove 0? That works. And is that better than yeah, filter not, discard. Those are all decent names. Discard is, I think, what, 1 letter more. Filter in and filter out. I know some languages use that. We could call it yeet. Yeet 0. Easter eggs. Pretty, although isn't there some language like didn't Rust I swear I saw some programming language actually use yeet as a keyword recently. Programming language uses yeet as keyword. Not yeetlang. I think it is Rust. Oh. So this is a stand-in term? It's a placeholder. Okay. Anyways, I wasn't wrong. I wasn't wrong that it's a thing. I mean, it's 4 letters, which is nice. But let's go back to our original solution of our old problem. And so technically we can replace this now with multiplication, remove 0, head, scrap, dump, drop. Drop is okay, but drop has like a different meaning because it's the same thing. It's the opposite of like take, or what Rust calls skip. I still think that this is unnecessary, though. Shed. Shed, dump 0. I still think remove is kind of my favorite, but that's because I have a C++ bike. Although I mean, we could call it yeet. We could call it yeet for fun. Yeetus deletus. Anyways, I still don't understand. Like there should be one function for this. Why it has to exist, right? I gotta be crazy that this doesn't exist. Filter. Should we just walk through them one by one? It's got to be a dyad. Like what could it be? Remove, delete, filter, compress, replicate, yeah. I just saw that Kai is the one that suggested sans, and Weewa also has this. For those of you not in the know, Kai is the creator of Weewa, which is a language inspired by BQN. And I haven't Weewa'd in a while. So I might get the syntax for this wrong. And if you go keep, you might need to have it the other way around. Or do you have to, right. I'm too used to Jelloing right now. So functions are always prefix in Weewa, whereas in Jello, you know, they're to the left, which we probably should change at some point. But so yeah, this is called keep. And if I understand correctly, the motivation for calling it keep is one, it's short, but two, it avoids sharing the prefix of replicate and reshape and functions like that. And why does this not exist in Jelly? This has to exist in Jelly. All right, let's go through these one by one. No. Permutation, no. Another permutation, permutation, combination, combination, return indices, nope. Find the first, nope. Trim all the elements, nope. Partition Y. We tried this earlier. So partition Y at the indices. Partition Y at the truthy indices of X. So I guess technically, yeah, this is kind of like the opposite of keep in terms of the truthiness, which is what we pointed out. And what if we have partition Y? So yeah, let's go back to what we called keep. So technically, if we go not, huh? I guess we got to do that. If we go not, and then we go keep, yeah. That's like worse though. So we went from index dyadic separator at index to not dyadic separator keep flat. So what are we at? The 30-minute mark? So it's kind of clear that this function doesn't exist. Unless if it's one of these dyads. Cartesian product, Cartesian power. Split. Zip. Let's just go through them all. Logical and, absolute difference, convert, 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 combinations. Count the occurrences. Div mod. Return the indices. Filter, GCD, head, hash, partition Y after truthy indexes. I'm surprised there's not like a K underdot or overdot for variations of this one. Logarithm, left, Ooh, what's modular? Mold. Decompression. Not equal. Logical OR. We already did the splits. So yeah, this just doesn't exist. And it's kind of irritating too that keep maybe the filter quick. Which one is that? It's C with a thing? Was there here? Can I just type filter? Oh yeah. What's this? Filter. Keep all items that satisfy. Oh. Well. I mean, yeah. Let's code this up. It'd be nice now that we've named it Yeet. Oh, look at that. That's brutal. Brutal. So, are you kidding me? How do we even type this thing in? Control V. Yeah. Yeah, it doesn't display well as an understatement. And then Python. Oh no, okay, it works now. All right. So if we go back to our simpler example, technically now I think if we just do filter odd, woo! Oh right, I think it's odd filter. Quicks go on the right. Right. So this is fantastic. But for the problem we're solving, we inevitably get a mask, right? We build up our our len iota mod 10 sequence, and then we're doing a comparison with the original sequence, which is going to inevitably give us this mask. So even though that quick filter quick, will be incredibly useful in the future, we definitely just want BQN's replicate and WeWa's keep, which doesn't exist. So, I mean, I think what we should do is should we try and go add our own to Jellyfish? The real question is though, is what do we call all these things? Filter. And also keep this is kind of like a bad name for this, you know. To do rename. This is really like not keep kind of thing. And if we're going to have a filter quick, it would be nice if these were kind of had the same prefixes, like filter out and like filter in. even though those are very verbose, and I guess it wouldn't be camel case. Like that would make this the longest. Which is kind of upsetting. Oh yeah, what is this? For K? We were looking at K earlier. K was after the truthy values. I mean, that shouldn't be too confusing. So 1, 0, 1, 0, 1. And now we're expecting, if we do this, we're expecting it to give us back 1, 2, 3, 4, 5. Yeah, which is what it gives us. So really this is, they call it a partition. I call it a split, or I guess Haskell calls these splits. I mean, we should rename that. It does make sense now. So what does it say? Oh, it's after truthy indices. Huh. So if we change this, it is kind of confusing as hell. Yeah, well, we'll leave that named as it is, and I think we'll just add these for the moment. And see what that looks like. So if we go 10 iota 0, and we go mod 3. So if we go filter out 2, filter out 1, filter in 2, and we could also make this a quick. Ooh, there is no even. How sad. Is there no even? Did I program odd? Where's odd from? Oh, that's right. It has to do with the binary. B over dot. Return. So there is no even. Sad. I mean, so what's the update here? We've got a couple different ways to spell this now. We've got after some investigation, 3 ways to spell this. There's the one that we have right now, index colon at index. There's this. And then we have the filter out. Was that what we, I think technically we called it yeet. But now this is filter out. Yeah, so times filter out 0. Which is very sad because this is actually the shortest way. Really, we just want keep. Not the. So should we call this keep? So, yeah, this is like keep not. Should we add it? Or not? Let's not for the moment, but we'll add an issue. Like keep from Weewa. Or replicate from BQN. And then add Weewa's. Actually, this needs to be created on the Jellyfish repo. Issues, missing atoms, edit. So we want Weewa's keep / BQNs. I guess it's just a slash. What do they call it though? It is replicate, right? Yeah, it's replicate. Yeah, I guess we can add the docs for this stuff. And then BQN, we have to go to the main page and go to and we will do this in another stream because I want to go we're technically, well, we're not up an issue. Yeah, we're not up an issue, but we still have not technically closed any events. So we'll give up on this for now, and then we're just going to go, let's go choose a couple quick problems to solve. So like I said, we're just going to cherry pick these because a lot of these problems are like just text ingestion, which I don't want to do. You're given an array of integers. The concatenation of 10 and 21 is 1021. The concatenation value of @ints is initially equal to 0. Oh, what? So 6 and 1 is 61. 12 and 25. Oh, I see. You're taking the first and last. I mean, that's kind of boring. Skip. We will. I'm not sure if I've ever done multi-dimensional stuff. 3, 7, 8, 9, 11, 13, 15, 16, 17. So there's no transpose. Trace. Once again, there's no way there's... Is there another word for transpose? Or maybe they do what Niel does, rows? Or is it column? Although it already was a column, right? How can there be no transpose? Another. Well, let's open an issue. Maybe Z. What is Z? Well, do I have Z in here? Huh. Well, it worked somehow. So if we go minar, pair with flip. Actually, let's do this one first. Flip, minar, pair, minar. Well, that's not what we wanted. I guess we need to for real? Huh. Why is this not working? So we have min r. If we pair with id, that gives us the original. It was not happy with that. Oh, because flip needs W. Does it? Whew, it's very not happy. Oh, this doesn't even work. Yeah, there we go. Yeah. But that's not even what the problem asks, right? The problem asks for something else. If it's both the minimum in its row and maximum in its column. So once again, we have to do, well, I guess we don't need the pair anymore. We can just go. And then this is odd that we're back in the same situation. So then if we go multiply by when we're in the same situation, filter. And this ignores when there's no lucky element. But technically, you could just do this, right? Whoa. Whew. Wow, we'll just ignore it for now. Oh yeah, I guess we gotta go commit some stuff. This is just the filters, right? What happens if I format this file? Is it gonna look terrible? Oh yeah, terrible, brutal. Hell no. I guess if I do this at the bottom, you guys can't see. Now if we go back, zoom in a bit, go back to challenges. This is, what was it, 251 P2? And damn. How do we do do we need a triple back tick for? Is it just a double back tick? Or is it just a slash back tick? Or is it a triple with spaces? Oh. I guess it's not here. You need this here this here. There we go. What is this called? Lucky numbers. This was a leak code problem that they just totally stole this from leak code. Let's go see, what was that, 251? Let's hope that these problems are bad so we don't have to solve them. You're given an array ints. Write a script to find the sum of the squares of all the special elements. Man, they're just ripping these straight from leak code. Do you know how I know this? Because at CPP North last year, I gave a talk, and at one point, I solved the problem, or was it in composition intuition? Yeah, it was in my other talk. Whoops. And look at this. Sum of finals of squares of special elements. And I solved this. And this was a leak code problem at the time. I bet, look at this, 271, 19, 18, 3. I bet the exact example. It's all right. I like this problem, so we can solve it again. If you want to see me solve it in BQN, you can go and watch here. Actually, I'll give folks the timestamp as well. Share, timestamp, copy. If you want to go and watch that, but let's do it in Jelly, and we'll use 1, 2, 3, 4. So we're gonna go len iota. Actually, I think that's it. Nope, I guess it's not. Is it iota len? It's iota len. Well, what is it again? I can't even remember. I think it's divisible by if the number divides into the length of the list. That's what it is. So if we go len and then div. So there must be a remainder too, right? Or is it mod? Right, mod. Ooh, what if we use the keep now? Does keep do what we want now in this case? It does do what we want now in this case. So if we do this, we can go flat. Ooh, it didn't work. Why not? Interesting. Right, because keep is dyadic. And then if we do square, sum, we're done. Interesting. But like keep is not what we want to call this. We want to... And actually, is that really what we want to do? We want to go not mod? Not? Huh? Isn't this just 1 minus? Do I not have minus implemented? And also, what the heck? mod. Right. So if we do this, and then we do square sum, is that shorter? Then len mod keep flat square sum. This is what? 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7. So technically this one, in Jello, it's more characters, but it is shorter in... It's shorter in Jellyfish. I mean, there must be a divides too, now that I think about it. Div. If x divides, look at that. So like, what is that? Divisible? Is divisible? So yeah, is divisible. What do we call that? D underdot? Or just divides? Ooh. Technically, we could add a question mark. To all our and odd. Where's odd? I mean, I might change my mind about that, but and then technically we can just call it divs. Short for divide. So not what I wanted. So let's try this again. So now we want len we have to flip it. Ooh, except I'm pretty sure we can do divs len, right? Oh, beautiful, folks. Then we can do multiply. Then we can do square sum. Whew! That's pretty nice. That is pretty nice. Look at that. S Combinator, the hook. The hook, you gotta love it. You gotta love the hook. Where am I going? I'm going over here, going to challenges. So how do we do, technically, you know, this is both. This is both PWC 252 P1. And then I'm pretty sure if we go to my GitHub and we go to content and we go to talks and we go to CPP North and we go to composition intuition and we go to links. Did I not link the... I definitely linked it. Once removed, if we go to this, sure enough, except I'm not going to be logged into LeetCode, will I? Sure, whatever. Skip my tour, sign in. Oh, that's not my username. Hey, there we go. So 2778. I don't actually know what contest this is. And then GitHub emojis. Arrow. What do they call this? They call it special numbers. Let's see what the next one. Unique sum 0. You are given an integer. Write a script to find an array containing n unique integers such that they add up to 0. Yeah, that's kind of boring. So we're not doing it. 253. This looks like a double skip. First one strings. Boring. All right, we've only got 4 days left till we're caught up to date. Given a positive integer n, write a script to return true if the given integer is a power of 3. Reverse vowels. I mean, this one should be pretty easy if there's a root. There's no root. I mean, we can solve this roughly speaking. It's kind of inelegant though. Maybe we won't commit it, but so 27. You can just choose some like arbitrary large number. Like is 50 large enough? 50 iota. PAL 3. I think that's way too large. Yeah, that's fine. What? This is not right. I think we need C in there. Yeah, that's way better. Although, what's going on here? Ah, right. Because we have 27. It is... It is trying to use that. And we don't want to use that. So basically, I was just trying to construct a list of powers of 3. Yeah, how do you actually do that? How do you continue to ignore 27 when you want to apply a dyadic function? And note, this is broken. Yeah, let's come back to this at a different time. Next, 3 days left. These are both string-based. Skip. Both string-based again. Skip. And last but not least, write a script to find how many integers are smaller than the current. This is also a leak code problem. Uh, 5216. Write a script to find out how many integers are smaller than the current. So this is just an outer product. This is super simple in BQN. So what was it? It was 5216. Just irritating. This is that's it, right? Huh. Yeah, isn't that the answer? So yeah, it's just an outer product W combinator with a row-wise reduction, which is beautiful. 5216. Can we do this in 5216? There does look to be an outer, and if we do less than W, and then we do sum, except we want to do a flip sum. Or I guess actually we can do a sum each. That's also very beautiful. Very beautiful. Yeah, I've seen, this is also a leak code problem that I've seen before. This is what, 57P1. Ooh, once again. Should we go find the equivalent leak code for this as well? Come on, you don't link to the how do I search? There's no search. There we go. Yeah. Here it is, folks. At least they didn't steal the exact examples this time. This is what, 1365? Let's see, how did I solve it? Did I solve this before? What did I solve it in? Ruby? It's not great. Not terrible, but also not great. What is this? Ugh. Ugh. When did I write this? 2020. That's not great. What was my wrong submission? C++. I don't know what I was trying to do. What were we doing? Right, 1365. And we'll grab this, copy, paste, and that will close one issue at least. So we added divs. And whoops, kind of hit ourselves. What? Oh. Git reset. I haven't done this in a while. Yeah, that worked. Solve PWC. Right, keep forgetting to do this. Challenges. Come back here. Close this, close this, close this, this. Keep that open. Close this, close this. And closes that. Come back here, that's closed. So yeah, we've got 30 minutes left, maybe. Let's see how hard this is gonna be. Or did he answer it himself? So let's check this. I was expecting phi 1. And then Yeah, there is no uh phi1 is a 222. I see. So they wanted to Is this a super advanced lambda calculus? No. This is just combinatory logic. These are combinators. So for instance, the W combinator takes a binary function it takes a binary function f and turns it into a unary function that just passes the argument x to it twice. So if you type W, ooh, look at me. So the W combinator is a unary yielding unary function, meaning that it's a function that takes one argument, and that argument is a binary function, and it returns you a unary function. And look at that. So clever that I coded this at some point. Right, but this individual wanted to basically add 1 to only one of these or something. Yeah, they only wanted to add 1 to the left argument and then multiply it with the right argument. So that means that in the 1, 2 example, you end up with 4. I think you can also just do this, right? Yeah. Does that work? Or is this actually, that's the W? Yeah, that didn't work. Yeah, so what they did is definitely correct, but is that the only way you can do it? Because add 1 by itself will just monadically apply to the first argument, which is why you get 2. So actually, let's make this 1 and 10. Just so that the add 1 doesn't equal the other value. So now is there a way to multiply this? Is there a way to multiply this with the right value? I mean, definitely the way you would do it in BQN. If you had 1, 2, you'd do a 1 plus with partial application. You'd pair this and then do identity. Why is it 3? How is... Oh, right. Because you need to do this. Yeah. So once again, if we change this, this should now be 20. What? Yeah. Very irritating. Is that the best you can do? It's kind of. I mean, it's gonna look a lot nicer if you just do it. Right, but you want this to be the other way around. Yeah. Well, is it nicer? Yeah, I think it's nicer. But the question is, so I think what they've done is the right thing to do. Just L add 1 and then binary times R. I mean, I think you could go... like this as well. You could create a list and then do a product. Yeah. But I think they figured it out. Yeah. $20 minutes left. Is there anything else worth trying to do in 20 minutes? Should we end at 20 minutes early? Issues. Dyadic separators. So we've got left, which is 1. Then we've got plus. Glad to hear that. Mega Paco Quinoa? Quinha? Yeah, that was a while ago we did those lectures. It was a great book. Yeah, I think I've actually already have an outstanding bug about this. Like, what is it supposed to do when you create... Yeah, I have no idea what it's actually supposed to do when you've got a dyadic function after a dyadic separator when you have 2 arguments. What are they saying? Well, actually, let's feed this to... Let's feed this to Jellyball 1, 2, run. So this is left, which gives you 1. What? Stop this. Oh, I see. So it's left, right, which is 1, 2, plus. Yeah, we're not going to fix this right now, though, but that's definitely correct. Correct about this will... at some point. I think maybe that is where we'll call it. Well, I can answer this last question. Do I have recommendations of books? I mean, I think Sick P is one of the best out there. I mean, the other books that Programming Languages Virtual Meetup has covered is Category Theory for Programmers. Yeah, this book. This is more esoteric and less quote-unquote useful than Sick P, but still very interesting. We also read 7 Languages in 7 Weeks. This is a pretty good book as well, especially if you go through the exercises. But yeah, I'd say Sick P is like by far the most impactful book that I've read. And I plan to go back and read it again at some point because it's, I think, so good it's worth rereading. Any C++ ones? Oh, yes. Elements of Programming.com. You can get this for free now. Yeah, written by Alex Stepanov. I will leave this in the chat. Yeah, even if you just read the first chapter, this book is probably like considered the Bible of C++, design. Alexander Stepanov is the individual who originally brought the standard template library and the containers to C++, and C++ is a much different and better language today because of all that, in my opinion. Anyways, with that, we'll say thanks for tuning in. If you're watching this on replay, hopefully some of that was illuminating. And in the future, yeah, we're going to come back and solve a bunch more of these. Maybe in the next stream, we will rename some of the partition and split functions and add the keep, and rename the current keep to keep not. But yeah. All right. Have a good night, folks.